Okay. Anyway, welcome to week 4. Whoever's not here and joins later can just catch up. I'm sure since the beginning of the class is kind of to go over the homework. So as of yesterday or 2 days ago, I looked at everyone's submissions on the Google Classroom. Everyone remember to do that, please. It's just so I have a way to know if the challenges are on the right level, if they're interesting, too easy. It's hard to get that feedback if I don't have a lot of submissions. So thanks a lot to those of you who have been submitting. One thing I want to add is up to now I said like STL files are good, but if it's fine, step files would be preferred in the future, just because it's easier for me to download the model as like a solid body rather than a surface mesh. Like you can see here, that's what happens with an STL. It's not that it's a problem, but it would be appreciated. Here's some more excellent mugs, pencil. Great. So if anyone had any problems they want to bring up regarding CAD, any debugging issues, I'd also be happy to address those at the start of each class. But since no one says anything, we'll get into the new week's content. As usual, if at any time you feel like I'm going too fast, too slow, feel free to speak up, ask any questions. To give you an overview, we're going to go over a few more features. Some of these you've used before, some of them maybe you're less familiar with. These are going to be the wrap, feature patterning, using planes for the first time, and a helix. So I picked up some challenges for the week. I kind of want to show you them before we get started, just so you have them in the back of your mind. Maybe if you're already familiar with a lot of these tools, you can start working as I talk. But the first one is kind of oriented at those of you who are kind of interested in mechanical engineering, maybe interested in cars. I picked apart from a drive shaft in many cars, especially ATVs, where you have a joint that allows you to transmit power from, say, the output of a transmission to the wheels or the top of the drive shaft. So we have this little part here, looks kind of like a spider. It's sometimes referred to as a spider or the inner race. So it's a very interesting part. I think you'll enjoy thinking about how to make this. Once you figure out the concepts and like the process of how you would make this, it's fairly straightforward. So very, very interesting. You can assume that all of these circular curving parts are all actually circles. So you can assume this is a circular arc, this is a circular arc, and this channel is also following a circular arc. I'll show you the 3D model later as well, but the slides are all in the Google Classroom, I believe. Let me know if you can't access those for some reason, but that's the first one. Second one this week, box of chocolates. I put up some guidelines on what each one should be, just for the sake of making sure you get some practice with all of these new tools that we're using. Each of these hopefully requires one new feature that you learned today or last week. So none of these should be like too much like busy work, but hopefully you learn something different from doing each of these. I guess the box is the least necessary of the 5 things, but I'd start with these chocolates just so you get familiar with the various features. And the third option is a water bottle. Maybe you've seen one like these before. It's basically 2 parts. You have a bottle and the cap. And I'd say the main new thing to be learned here is doing the male and female threads. And the rest of it you should be pretty familiar with. So I think there's a good mix. You can start thinking about them, maybe start modeling them, but I'll get into starting some quick demos on various tools. So I guess any questions about these three before I start? And if not, here we go. All right, so to motivate the first thing that we'll be talking about, I'll start by talking a bit about sketches. So usually when you start making a model, you start with a sketch. And what you'll notice is that all sketches have to be done in a plane. It even says so in this little window. It asks you to select a sketch plane. And so no matter what I do, just from a single sketch and extrude, I'm always going to end up with a bit of a flat surface here because I started off with a sketch that's in a plane. So anything that I draw in the plane, even if it's curved like a circle, in reality, it's just a flat object, right? The cylinder is flat on this face because it started off as a sketch in a flat plane. But now let's say I have a curved face like this curved face of the cylinder. And let's say that I wanted to extrude something off of the end of it. So say I have this water bottle, imagine it's a perfect cylinder. If I wanted to extrude something just off the face of the cylinder, it's not immediately clear how I would do that. I can't just select this face and tell it to start a sketch because it asks me to select a plane, and this curved surface is not a plane. So it's true that I can't draw directly on this, but there's a feature in Onshape that allows you to effectively draw a sketch on a curved surface, and then you can do what you like with that sketch that's curved. And so before I can show you that feature, I have to show you, I guess, a different feature that's somewhat related. You have seen these before in the earlier CAD classes, but maybe haven't used them that extensively, and that's these reference geometries. So towards the right of your feature bar, you'll see by default, you have a drop-down menu with the plane icon. Maybe if you have a really wide monitor, these are all like visible next to each other on the bar, so there's no drop-down, but you'll see something that looks like this. And if you hover it, it says plane. And so this is really important. And it's something that appears in almost all like CAD programs. What it allows you to do is essentially create another one of these things. So every Onshape document that you start, every part studio that you start gives you these three planes, right? And these planes are pretty critical because all the sketches you've made so far have usually been on one of these planes. And so the reason the plane tool is so powerful is that it lets you create your own planes where you can then create sketches that don't necessarily have to be on these exact three planes. And so I'll demonstrate that quickly. It asks you to select entities in the window, and that can be a lot of things. It can be a part face. It can be another plane, which is what I'll do right now. So you can see I selected the front plane, and that creates a new plane called plane 1 that is offset by an inch in this direction of the arrow. And having made this and accepting it, you can see now, just like the top, front, and right, I now have plane 1. And this plane 1 acts just like any of these top, front, right planes. You can do pretty much the same thing that you can with the original three. And for instance, one of those things would be creating a sketch. So I opened up my sketch window, and when I'm selecting a plane for the sketch, I'm now picking plane 1. And what you see is that the sketch, this little light box here, is on plane 1 rather than on any of the three original planes. And whatever I draw here will be in this plane. Now, to get back to what I was saying about sketching on curved surfaces, let's say, for example, that I want the cylinder to look like a tire. A tire with like big tread blocks, right? So you can see like an ATV tire has these big blocks and grooves and all these patterns that are on a more or less cylindrical surface. And so from what you have right now, you can't just draw these tread blocks on the cylindrical surface and extrude them. But what you can do is do something like this, where you create a plane, have the plane be offset from the surface on which you want to draw these things, and kind of illustrating my tire example, let's say that I want some tread blocks like this, maybe another tread block like this. Whoops. I'll just do 2 for the sake of keeping it quick, but you can see I drew my sketch here of my tread blocks. And what I can do is use this feature called it's called wrap, and its location is here. If you ever can't find something like that, you can do what I just did and click every button, or you can also use the search function. It's wrap. I usually search for it, but I figured you should know where it really lives, which is under this menu. So you have wrap. And so what you're going to do is take your wrap, you'll open up the tool window, and what you have is an option to select tools and a target. So I guess I'll show what happens and then I'll explain what happened. I'm going to select these sketch regions that I just drew, my tread blocks. And as my target, I'm going to pick my cylinder face. And what I'll do is I'll change this top option from surface to solid. Surface is useful too, but we haven't talked about surfaces yet. So solid pretty much does what I wanted, which is to make these tread blocks on the cylinder. I can change the thickness of it, can make it thicker, can make it thinner. And that's pretty much all I have to do. And you can imagine if I then pattern this using a circular pattern to just go around the entire cylinder, I'd have something that looks kind of like a tire with the tread blocks. So to sum up, that was kind of 2 things there: learning how to make a plane and learning how to use the wrap feature so that you can extrude things onto a curved surface. All right, I'll take a moment for questions on either of those 2 things. I see someone joined the class between when I started that and just now, so in case you missed it, the slides are on Classroom as usual. 3 challenges for this week. We have our constant velocity joint spider. It's this little inner race of a part on a car. Second option is some chocolates, maybe make a box to put them in. And the third option is a water bottle. So keep that in the back of your mind as we go through a few more demos. And at any point, interrupt me with questions. So that was the wrap. I'll go into a bit of a related item now, which is also has to do with putting features on a cylindrical surface. So I'll just delete everything and we're back to square one. let's say that, again, I have a cylinder. And let's say today I'm trying to make a bolt. And I know I've said before, you should not really ever have to CAD a bolt, but today it's a educational experience. So we will do one so that you know how to do one. So let's say this is the, I guess, shaft of the bolt, the threaded portion of the bolt. And what you'll find is a lot of CAD programs have a built-in thread feature where you can select a cylindrical surface and just select one of the standard threads that are associated with it. And you've seen these threads before on master, on top charts. It's like things like 1/4 inch by 20 or number 8. Onshape, unfortunately, does not have that built in, but it's an interesting exercise to figure out how to make threads given that you don't know them. And it's still sometimes useful because sometimes you might have to make custom threads. You might be single point threading on a lathe and you just need to design some crazy thread that has a weird profile and different features. And the way you do that is with a helix. And a helix is a pretty common tool. You'll see this in other CAD packages, even if they do have a built-in thread tool. So it's also pretty straightforward, which is very nice. I have the option to select a conical or cylindrical face. And so that's that right there. And I can specify the direction, clockwise or counterclockwise. And I can say the number of revolutions. And what you'll see from just looking at what happens is that's the revolutions over the length of the entire face. So if you're interested in like a threads per inch, you can calculate that pretty simply just by knowing the entire length of this rod. So let's say I want something a bit tighter, maybe 10. And I'm happy with that, so I'll accept it. And here I am now with my thread. You'll see it's not really a part. It has its own category in this like feature or object menu where I can see that it's a curve. So that's pretty interesting. It's kind of similar to if I had drawn a line in a sketch where I can interact with that line. I can select it for, say, a sweep pattern, which is what I'm going to be doing. So in my case, I want to make some threads. So what I'll do is I'll create a sketch in the front plane and observe in my case that the front plane does go through the helix, which is fairly important. And what I'll do is I'll draw a triangle. And this may not be completely accurate to the standards for thread manufacturing, but I'll make an equilateral triangle just for simplicity. Say around that big. And what I'll do is I'll just drag the triangle to my helix. If I want to be really careful and make sure that I'm actually selecting the helix and not the boundaries of the cylinder, which could also happen, what I can do is use my ability to hide things. So the cylinder is part 1. I'm free to hide it. And what I can do then is just connect the triangle to the helix and it'll automatically create that coincident relation. You can also just manually make these coincident using the relations that we have. And having done that, you can see where I'm going with this. I have a profile and I have a path. And what I want to do is essentially sweep this little triangle around the entire helix all the way down. So I'll turn on the visibility of that part. And from here, I'll do what I did last week with the sweep function. For my sweep path, I'll select the helix. And what you see happens is I get a thread. It's rather sparse. I guess 10 revolutions over 3 inches isn't actually that much, but I can also change that from the helix options. Maybe I'll double it. You can see I get a bit of a tighter thread now. So that's how you make male threads or external threads. And for the internal threads, like you might need for the water bottle, you kind of want to think about how you would do that. I guess not to give too much away, but you'll see here it's kind of the opposite, where the threads are on the inside of the diameter of the circle. So that's kind of the main challenge of the water bottle if you choose that one to do in class. But in terms of the before class talking session, that's pretty much all of what you need to know. Just based on what you have and what you've learned in the past 2 weeks, you should be able to hopefully make these 3, but if there's anything that you run into, any problems with any of these, just feel free to ask a question. And with that, I'll let you be for another 10 to 15 minutes. I might come back and ask people to show me what they're working on, and we'll get back together at the end of class. Thanks. For those of you who do select the spider, this shape might not be immediately clear just from that still image, so I'll rotate it around a bit. What you'll see is this surface kind of curves outward, and also that this surface, it's kind of saddle shaped or Pringle chipped shaped, where from this direction kind of curves, has an upward curvature. From this direction, it has kind of a downward curvature. So it's a very interesting shape, but you have learned tools. In fact, last week you learned a tool that you can use to create this. But if you're stuck, you can feel free to ask. And once again, the slides are on Classroom. No one said they weren't able to access it, so I'll assume it's available. I guess sorry to jump back in so quick, but I did realize not everyone was here for CAD 2, so you might not be familiar with the text tool as well, which we did, I believe, cover, but it is relevant for one of the chocolates where it asks you to write a word on it. So there's no need to try to trace out letters. There is a built-in function for it. Maybe you've run into it before. It's the one with the letter A in it. So if you select that one, you can kind of select a region like that and then put some text in, and some font options as well. And with that, you're able to select the text just like any other region. And it acts like a boundary, so I can extrude something like that. So I guess just as a refresher, if you forgot how to do that, oh, and I'm forgetting a lot of things, apparently. I did not show the feature pattern. Um, you're all quite familiar with patterning in general by now, since you made all those sprockets and gears. So it's not too much of a stretch. It's very similar. I'll show a linear pattern since I have a thing going here. The main thing to be wary of is just that this first item is a dropdown, so this is probably where you'll have problems, if any, because the rest of it is a lot like what you've done before, but what you have is the option to pattern apart, which is what you see in the bottom here. This entire thing is a part. So if I part pattern, I can only select the entire thing. And I can pattern that if I wanted in any direction, like so. But what I can also do is pattern a feature. So that's the things in this feature tree. For example, this extrusion. I guess in this case, it's hard to tell what the difference is. So let's say I'm trying to make a block with a lot of holes in it. And I could do this in the sketch with a sketch pattern. But some would say that it is more robust to do it in a feature pattern just because it's easier to edit things that way. So right now I have a extrusion with an extrusion cut. I cut this hole out with a second extrusion, and that's a feature. So if I wanted to pattern this, instead of having part here, I would drop down, I'd select feature, and instead of selecting the whole part, I can now just select a single extrusion. And like that, I can pattern the extrusion. So instead of patterning the circles in the sketch, I drew one sketch, extruded it, and then patterned the extrusion. The subtle difference. But you will need that for the spider, or it will make your life slightly easier since you don't have to do the same thing 3 times. In a couple minutes, I'll start calling on some people. Don't worry if you're not finished. And that goes for submitting at the end of class too. I know most of you are in the group or in the classroom right now, but I don't get submissions from everyone. So even if you're not done, and even if you just want to submit an image, that's fine as well. Just at the end of the class, get in the habit of just putting what you have on Classroom. And bear in mind, of course, that you have a lot of creative freedom. The bottle doesn't have to look like this. The chocolates don't really have to look like that. I just want you to use a lot of different features. The spider, I guess, has the least variety, but hopefully if you choose it, you find it interesting enough.
How did you like snap the corner of the like this screw thing to like the helix?
Could you explain what you mean?
Like how'd you snap the corner of the triangle you made to the like the helix
Oh,
shape?
okay. Yeah, I know what you mean. All right, so I'm guessing you find yourself with a helix. So you made a sketch of the profile you want to sweep, right?
Yeah, I made a triangle.
So you have a triangle. Like I did before, I'll just make it equilateral, even though it's not maybe the most realistic thing. So when you have something like this, helix, and it'll